Okay, so I guess we should start now. This is like an extra session for this course. I don't know why it's placed so early, but yeah. So today is Sunday. I don't expect many of you to join, but if by any chance you're not able to join, there are always online session recordings. You can go there and have a look there. I didn't plan of in having an extra session as in teaching you something new, but we'll just follow the course contents and schedule. So what we'll do is like we'll solve. I have made up of some set of questions and we'll solve them. These questions are like all based on the weeks that we have been studying till now, and so that it will help you for your exam also. So this is like set one courses are usually like this 4 and 8 week courses. So your exam are like due in April. So try your best till then. Yeah, and then we'll meet again on Tuesday to discuss for week 7, and then later next Tuesday for week 8, and that's how your entire course will be completed. Okay, so let's just start. I'm Jagrati. I'm a fourth year PhD student at IIT Gandhinagar. I work with Professor Kala Mercado Shekhar in the Medical Ultrasound Engineering Lab. Okay, so this course was all about introductory mathematical methods for biologists, and we started off from basic functions, graphs, and then when we looked at its Taylor series expansions, then later we went into differentiation. We looked at different rules of differentiation. So the first thing that we'll do now is like we'll do some differentiation. Okay, these are like the major concepts that you should always know. Then we went and then we looked at integration. So integration there also we looked at definite, indefinite integrals. Post that we looked at what did we look after the integration? We had like different solvers. After the rules and formulas for integration, we looked into diffusion, the current flows, and hence now we are looking into scalars and vectors and concentration gradients, those things. So same things we are looking again. So this is like just for your practice so that you know how to solve enough questions into it, and it would be easy for you to go along. Okay. So I'll just begin. I have a set of questions. If you are not able to solve during this session, I can upload them in the drive link that you usually from the sheet where you usually get the contents about the online session. So you can always go back and check it there. Okay. Just- Yeah, so we'll solve few questions. Um, these all questions are like will help you for your exam point of view. Okay. Yeah, so beginning with the first, that's differentiation. If people later join, I have already given you mic access, so I expect some participation from your end. Okay, and let me adjust my windows. Yeah, there we go. So we have like first question, we'll go into differentiation first. Let me know if my handwriting's not visible. I can maximize the window. Mm, yeah. Right. So first question is, so let's start with simple. If f of x is given as x power 6, what would be f dash x? That is df by dx. What would be that? So here it's a simple power rule. So that's a thing, but if you have x raised to n as f of x and you want to find f dash of x, it would be nx n minus 1. Okay, so here also you have 6 x n minus 1 is right. Okay, Similarly, like there are some quadratic functions. So if you want to try, I can just leave it here, like 4x cubed minus 7x plus 5. Okay. Now what happens? You have a power here, you have a x1 here. So when you subtract it, it becomes x raised to 0. So you only have a 7, and this is a constant. So we learned that derivative d by dx of a constant is always 0 because it does not have a derivative for it to derive with respect to. Okay. So this would be 4 times 3 x power 2 minus 7 plus 0. Okay. Next is like, what's the derivative of a sine? So for sine, for now, you already know that either you can do it using Taylor series and differentiate the Taylor series function. You can see, and we already did it using in class on the previous cases. So if you take a derivative of sine x, you get cos x. Okay, that's done. Then there was this function that you all should know till now is e raised to x. That what's the derivative of e raised to x? It remains constant. So that is nothing but e raised to x itself. So we saw it using its Taylor series also. You can go there and check it back. Differentiate the Taylor series of e raised to x. It again comes the same thing. What it was like 1 plus x power 1 plus x, I guess, plus x power 2 by 2 factorial plus x power 3 by 3 factorial and so on, right? It was like that. Another one, like for log x. Okay, now in this case, it is natural log x. So log, like this is nothing but log to the base e of x, whatsoever it may be. When you take derivative of it, it is essentially 1 by x. That's it. Okay. Now, in this case, it will ask us to do something as chain rule. So what is simple for us to do? You use change of base formula, right? So this is like, now you know this is log base e of x. The derivative that we know is log base 10 of x. Okay. So change the base here, make it as base 10x and make it as 10 base e. Now you know you have like 1 by log base 10 is e and you have 1 by x. So that's a derivative for your log x. Okay. So this is essentially your function till here, f of x, and this is your f dash of x. Okay. I hope it's clear. I don't see anyone join till now, but if you have further questions, you can always add comments in the YouTube channel. I'll try to YouTube playlist. I'll try to get back to you through there. Okay. The next question. We have question 7 as f of x is equals to x square and e raised to x. So what do you do here? You have something as product rule, right? Now, what does this product rule will give you? What does the product rule say? That if you have u comma v, u dot v, you'll first derive. So I'll just write as the derivatives as dash here. Okay. So this would be u dash v plus it would be v dash u. Okay, that's it. So here, if you want to do for f of x, the first one is u, this is v. Okay, any random thing you can do. Either the second can be u and first can be v. Okay, so first let's just derive u and then keeping v constant plus derive v, that's e raised to x only, and keeping x constant or u constant. Okay, that's it. There you go. That's your answer. Yeah, that's that simple. Similarly, I'll add this in here. You can solve it by yourself. If it is given x square is equals to x sine x. Same chain rule you need to follow over here. Okay. Then there's a nice one for quotient rule. Okay. So we already studied that quotient rule can also be solved using product rule. Instead, you can take the numerator out and multiply it with the denominator. sorry, denominator out and multiply it with the numerator. So if you have something as x square plus 1 whole by x, okay. Now what do you do here? You take the denominator outside. You can either write it as 1 by x times x square plus 1, or you can either consider it as u by v, okay. Now for a quotient rule, the formula goes as you first derive the numerator, so u dash, keep the v constant, minus you derive the denominator, so v dash, keep the first one constant, divided by v square. Okay, so that's how divide by v square. So denominator square. So in this case, what it would be? So you have first your, so let's just write f dash of x is equals to, first derive your u. So u is nothing but 2x plus 0. Keep this constant, minus derive your v, that's 1. And then you have keep your upper one constant and then take square of this term. That's it. That's your final answer. Then you can rearrange the terms again. You'll see, you'll get the answer there. Okay. Next one. That is e raised to 3x. Okay, so this is something as e raised to 3x. So what does this follow? It follows chain rule. You first need to understand that which particular function follows what. Thereafter only you'll be able to solve it. And this comes after you solve n number of problems. After that only you'll be able to understand. So let's say here what it's written as e raised to g of x. So when you're trying to differentiate this one, so how it is, when I'll try to differentiate e raised to g of x, it would be like I'll write this e raised to x as e raised to x, and then this g of x, I'll have to differentiate it again. Okay, that's my chain rule. So how do I do for this, the function that I have now? So just input in the values and g of x, differentiate g of x, that is nothing but 3. That's it. Okay. Then using chain rule, you can also do something for this one. I don't think so that if you have seen example like this before, you can try for ln of x squared. Okay, you can either do change of base theorem, but here also the theorem formula that you'll apply is chain rule. Okay, so try and substitute this as g of x, let's say, and then see what happens. So log of g of x and then later of x squared. Okay, so here in this case, it would be 1 over x squared and then you have 2x. Okay, so something with 2 by x would be the answer here. Okay, then you can try for this one as well. So f of x as x cube cos x. Same. So here you'll apply product rule. Okay, so that's it for differentiation. Let's just see now on integration. Okay. Now, for integration, for let's just first take simple one. So we'll take something as definite integrals here. Okay. For definite integrals, let's take something as x power 4 d of x. So how do you differentiate it? When we have something as x raised to n d of x, you do it as x raised to n plus 1 by n plus 1. And since if it's indefinite integral, you don't have the initial conditions here. So you'll add plus c in that case. Okay. So here it would be x raised to 5 by 5 plus c. That's it. So that's your integral output here. Okay. Next one. Now I suppose you'll be able to do this. So 3x squared dx. Now when it is like that, and this is not at all dependent on x, or it is not a function of x, so you can take this constant outside and then you can integrate dx, x squared dx. Okay. Similarly, we can do it for sine. So when we also tried differentiating and integrating the Taylor series back and forward, we did it for sine or cos either and one e raised to x function. So for sine, you know that it's directly a cos x. Okay, so for sine x, it is when we differentiate sine x, no, sorry, integrate sine x, it's a negative cos x. Whereas if you integrate cos x, it's a sin x. Okay, again you have c here. You can do it for other trigonometric function also, the ones which are left. You can try for tan, cot, sec, and cosec also. Okay, sec and cosec are essentially inverse of sine and cos, and tan is another function which is like a ratio of sine and cos, and then cot is like inverse of tan there. Okay, then another function, so which has similar properties in integrals and derivatives is e raised to x. What does e raised to x has? Whether you integrate it or differentiate it, the function remains the same. In this case, it is indefinite integral, so you'll add a c in this case. Okay. The other question, you have 1 by x dx. So we just saw now for log. And if you don't know, check out its Taylor series back and try differentiating it again. You get the function here again. So this is nothing but corresponding to log x plus c. Okay, that's it. So in any of the cases, it's fine. It can either be natural log, so log base e, or it can either be log base 10. Based on the question, howsoever it is defined and the initial conditions given, you can solve it back. Okay. Now let's jump on to indefinite definite integrals. So let's just say I'm trying to integrate x square dx from 0 to 2. Okay. How will you do that? When we have a function like this, you already know that this would be x cubed by 3 and this would be added as upper limits here 0 to 2. So now insert 2 in terms of x minus 0 in terms of x. Okay, so you have 1 by 3 as constant. Take it out. You have this 2 cubed 8 minus 0 cubed is 0. So your answer is 8 by 3 here. Okay, that's it. Questions are easy. It's just that you need a little bit of practice so to get an hang of it. Okay, next one. It is simple. So it is nothing but you take of x dx and now it's from 0 to 3. Okay, I guess you'll be able to solve this through. Similarly, next question is x cubed dx and it is 0 to 1. Okay, so that is also fine. That also you can do. Now next is try and integrate from 0 to pi sine x dx. Okay, what will happen? For sin x, when you integrate it, the answer you get is negative cos x. Okay, take like negative sign out from 0 to pi. Now, what is cos at pi? Is negative 1, right? So, cos at pi is negative 1 and cos at 0 is 1. So, minus cos at 0 is 1 and you have this minus 1, that's 2. This minus sign added here, so this is plus 2. Okay, so in this case, you know that if you're trying to see it, you can also do these questions by visualizing the graphs of it. So if you see over here, we look at that as 0, and this is pi by 2, then this is pi. Okay, so sine is like splitted in this function and it's already 1 in this case. So when you, 2 minutes, huh? Sorry for the disturbance. Um, yeah, yes. So here, you see that when you're trying to evaluate the function at this values, 3 by 2, and then you have 2 pi in this case, you know that for sine 0 to pi by 2, sine pi by 2 is 1. So in this case, this is 2. And later when we go this way, so if you try and evaluate the same function at from 0 to 2 pi, this area will give you plus 2, this area will give you minus 2. So it is both cancelled out, and for the entire graph that we have drawn here, it would be 0 there. Okay. Similarly, you can also do it for cos x. Like try cos x like this. So what is cos x? The derivative of cos x is nothing but sin x, right? And now you try sin x from 0 to pi. So what is sin pi? Sin pi is nothing, that's 0. And then cos sin 0 is also 0, so that is also 0. Now why this happens? You cross check it again. Of course, we'll after a point we'll only trust on the derivatives and integrations that we do, and we won't be having that certain logic on graphs. But graphs will give you like an idea that okay, is it correct or not also, because you'll see the nature how the graph is being varying. Okay, now for cos in this case, this is 0 because for cos 0 it's 1, cos pi by 2 it's nothing. Then this is 3 pi by 2. Oh, sorry. Then this is pi. Cos pi is negative 1, and since the one thing that we saw here, and then this is like 3 pi by 2, and again it go backs in this case, and this is 2 pi. Okay, cos is like an even function in this case. So you see, we're trying to evaluate cos from 0 to pi. Now from 0 to pi, so you have like this function here, this half right here, and you have like this half right here, which are like both symmetric to each other. Hence, they'll nothing but they'll cancel out each other. Hence, it's 0. Okay. So in any case, if you don't even want to integrate it back, just see how the function looks like. You know the answer already, because the questions would be like numerical for you. We'll have options for them also, so you can directly do that. Okay. Now this one. Okay. So you know the answer for it. So this would be 5x square by 2, and then this does not have, so this is nothing but dx. So what is dx? It is x. So this is 3x by 1, let's say by 1, and plus c. Okay, that's it. Next question. Let's just say for this one, you have something as 2x square plus x dx. Okay, how do you solve this? You solve it as you can like now integrals are nothing but additive in nature, linear. The property is linear there. So what you do, you can take them both out, separate them each other. So you have a 2 times this is x cube by 3, and plus this is x square by 2, and plus c. Okay, that's it. Next one is simple. So you just evaluate x dx and give it limits as 1 to 2. Okay, what it becomes there is nothing but x square by 2, you take it from 1 to 2, you have 4 by 2, and you have 1 by 2. So you have answer as 3 by 2. Okay, that's it. Now we'll shift our focus from vectors and dot product to vectors and dot product. Okay, so these integrals are done. You can even get more complex ones outside, but these are fine for you to solve till then. So vectors and dot product. Now, okay, I'll just pause for a minute here so that you can shift your gears back. So if I have, let's say, 2i, so think of the gradients that we learned, that if you take a gradient of a scalar quantity and if both are vectors, so if you multiply both vectors, how do you do them? So we also had a similar question in assignments where we multiplied the components and then added the components all together. Multiply the corresponding components and then add them back. Okay. And then this is like 4i plus j. Okay. How do you do that? Think for a bit. I'll be back. Yeah, yes. So how do you solve this? We'll just multiply the corresponding components. So in this case, we have as um, this is like 2 times 4, and plus we have 3 times 1. So this is like 8 plus 3 as 11. Okay. Similarly, you can do the next one, which is 5i plus 2j times I plus 6j. Okay. So you can solve this one and see how it comes. You just need to follow the same steps that we have, like I did previously. Okay. Now, next question is also similar to it. So if you have like 3i plus j times 2i plus 4j. Okay. If you do this, you'll also get a similar one. Now, in this case, okay, not this case. Okay, it's fine. Now, let's just take another one. So, which is like 3i plus 4j. Now, for this case, I want the magnitude of this particular vector that is written, okay, which has directions. How do you compute magnitude of the vector? Let's say this is a vector A, and to compute magnitude of a vector A, I'll do something as square root of 3 square plus 4 square, okay, which is nothing but 5, right? That's it. So that's how you take magnitude. Now, if someone asks you how do you take angle of a vector, how do you find the direction of it, you do something as tan of, I guess you do tan or tan inverse. Let me check it. Um, Computing angle of a vector. Yeah, so it is tan inverse, okay? So when you compute angle of a vector, it is tan inverse of the y quantity by x quantity. Now in this case, your y quantity is the one associated with j and this is the x quantity, okay? It's like this. So you have as tan inverse of 4 by 3. Whatever this might give you, the answer will nothing but in degrees. So you'll evaluate it in degrees and eventually convert it back, okay, based on the ratios. Okay, next one. This is a nice question. So let's say if a person is walking, okay, so let's just make our coordinate axes. Okay, now we have north, then we have south, and we have east, and we have west. Okay, so a person is walking 6 kilometer east. So 6 kilometer east, someone's walking. Let's say this is fine. That is a 6 kilometer. Okay, in our grades. And then he's also an 8 kilometer north. And then he is going back like this, 8 kilometer north. So he has traveled like 8 kilometer in this case. Find the displacement magnitude. So the total distance that he has covered is, now you know, it would be nothing but 6 plus 8. But what would be the displacement that he is traveling here? Now these both are like perpendicular axes. So the displacement is traveling from the origin from where it started was this one, right? Now how do you see this? This is a right angle triangle. Now you can solve this using Pythagoras theorem, right? And solve it using Pythagoras. So what would this be? This is nothing but 6 square plus 8 square, right? And that's your answer. So finally your answer would be 36 and then you have 64. So that's 100. So your answer would be 10 kilometer as displacement, right? Now keep in mind whenever we talk about displacement, even though this is a magnitude, so hence it's a scalar, but displacement is a vector quantity because it's associated with the direction. So what do we say now? Now we say that the person has traveled northeast. That's the direction associated with it. Okay. Okay. Next one. If the force applied is, let's say, 2i plus 3j, the displacement vector is given to you as 4i plus 2j. We need to compute the work done. This is similar to energy. So what is work done? Work done is nothing but dot product of force and this displacement vector that you have. Now, since both are vectors, you write it as this, but energy is a scalar quantity, so we cannot write it like that. So what do you get? You multiply 2 times 4, then you multiply 3 times 2, so the corresponding quantities with their own vectors. So this is nothing but 8 plus 6, that's 14. That's it. Okay. I expected some people to join today, but it's fine. I do understand that it's Sunday morning. Yeah. Similar question, you can try it on your own, and let me know in the comment section if you have any further queries on this, or also in the Q&A session of the course website. This is 5i plus j, and then we have the r vector as 2i plus 3j. Okay, what you need to do is nothing but take the dot product of both of them is the work done that you have. Okay. Okay. Another term, let's try that. If you have I plus 2j times you have 3i plus 4j plus you have something as 6k. Okay, what do you do now here? Now for k, you don't have anything in this case for here. So you write it as 0k. Okay, so it would be just as 3 times 1, 2 times 4 plus 6 times 0. Okay, so that is nothing but 3 plus 8 is 11. Okay, that's it. Now, after doing this once, we have a couple of questions on diffusion. So for diffusion, let's just see now. For the gradients and diffusions that we learned. So this is done. So we completed like three sections till now. Okay. We have like solved almost 30 questions by now. Okay. Let's look into diffusion. And differential equations. Okay. I forgot to write this. It's 8th March today, so that it would be carried forward. Yeah, okay, for diffusion. So let's say this is 1D diffusion, and I'm not making the questions as strangled as they were during the assignment one. For 1D diffusion, I want to compute the RMS displacement. Okay, the RMS displacement. The RMS displacement is what? It is given as 4 centimeter in 1 hour. Okay, this is the time also. So now they're saying compute the diffusion constant, or what would be this? Compute D where using this x squared. For 1D, you know that it follows something as 2dt, right? So how it would be? Now this is something as circular equation, and it's not part of your active transport for it to be directly proportional to time there. So how do you compute T here? Yeah, give it a thought, and then I'll solve it back for you. Okay. We spent like a minute, so we know that this value is being given to us, right? This for 1D diffusion, so time is given as 1 hour. In this case, time is 1 hour, and then you substitute this displacement x as the here, so x would be x square 16 is equals to 2 times d times 1 here. Okay, so this is nothing but d is equals to 16 by 2, that's 8. Now, what are the units here? So this is centimeter square, right? This is centimeter square. The constant you don't know. Now, if you know and remember from the classes, we already determined the unit for dimension there for D. So it was something as meter square per second, right? So now in this case, look here, this is R, okay? And if you don't want to convert it back, and since it's like we don't have an answer key or preliminary, let's say, specific details to follow here, so how we can go is as centimeter square per R. Now, if you want, you can convert it back. So it can either be 10 raised to minus 4 times meter square, okay, by, if you want to convert this to seconds, so you divide it by 60, and all those things you can do back. So you can also convert it back to meter square per second accordingly, okay. Now, next question. What's the next question? So you have given RMS displacement. So your X essentially is 6 centimeter. I know questions like this, direct questions like this won't come, but this is just for you to practice the formula so that you can remember it back and then compute the t. So you utilize the same formula that we did before as x square is equals to 2 dt. We'll get the diffusion constant here and write the units of it. So I'm just following the units that I have in the question here. So that would be centimeter square per hour. Okay. Next, so here I'm expecting you to solve this differential equation. So I'm having dn by dt as 0.5 n. So what does this represent? This is something as your growth curve or growth rate equation. Okay. So how do you solve it? Keep same terms on either sides. Okay. So this is dn. Bring n this side. Integrate it. 0.5. Take dt that side. Integrate it. So this is going to be log n, right? Is equals to this would be 0.5 t and plus c, right? Or something as that. Then when you have things like this, what you'll do? You'll take a exponential back. So you have n is equals to e power 0.5 t plus c, right? And when we saw this previously, that this is nothing but essentially e raised to c is n naught. So this is n naught times e power 0.5 t, right? So yeah, n is equals to n naught times 0.5 t. That's it. Okay. Next question. So next question is similar. Instead of just reverse the sign there for the constant in front of it. So now you know what will change in this case. What changes is the sign changes. So now you know already the solution here. So this would be n naught e raised to minus 0.3 t, right? It would be that sign. Okay, next question. So now you already have known that how the formula goes as. So if you have been given the variables as n naught as 100 and k as zero point 0.2, so kt is like that term right there. Now they are trying to ask us that write an equation for this exponential growth, right? So how would the equation for this exponential growth look like? So we know now this constant is positive, so this would be n naught times e raised to kt, right? So that would be 100 times e raised to 0.2 t. Don't even think a lot. That's it. Answer is that's it. Okay. Okay. The next question. So next is similar, but in this case, some terminology is different. That if n naught 50 and they are giving you a decay rate here. Okay. So now you need to understand the terms here. So decay rate as 0.1, that's essentially your k, and they are trying to ask you that write it for exponential dk. Now, when you say dk, it's essentially negative. So it's trying to reduce. So this would be minus kt. Okay. K is positive, but since it's dk, you'll have a negative sign there times t. And this n naught you can substitute it as back as 50. Okay. I hope that was clear. Okay. Now it follows something as the current flows. So using J as negative C, sorry, negative D, partial derivative of concentration, dC by dx. Now D is given as 3, your dC by dx is given as negative 2. You compute J here. What would be J? There's nothing with. You now know the terms. It's just 3 times minus 2. That's it, minus 6. Okay. Now what happened here? You have minus sign here, okay? So you multiplied by the minus sign also. This would be positive, okay? Other cases, if the units are asked, now you know how to solve for units. Others are simple, you can solve this back. Now let's go into logs and exponentials, okay? For this ones, I'll also say that go back to the last week's lecture and see its dimensions and units again, okay? Um, be proper that you know this one, the Einstein's formula, um, for viscosity and those things, okay? For rate, how rate changes. I personally, I don't think so that it should be there and you need to remember the formulas like that. But if it's being asked, then be like it's just a single or two formula, so you can have it in your concept, okay? Or else remember the derivative. So not the derivative, but the derivation, how to solve for it. So if something like that is asked, you can right away solve it and then you know the formula for that. Okay. Now it is logarithms and exponentials. So we have like 10 minutes left. I'll just quickly go through few examples and then the later the sheet I can solve it back. I guess we only have 10 questions left also. So we have like solved 54 questions, including this 10. Okay. Okay. So now they're asking us to solve log base 2 of x is 5. So how do you solve it? Now you know that the term that you're seeing over here is the exponential one, right? This what you're seeing here is to the exponential form. So x is nothing but 2 raised to 5. So that is 32. Okay. Next one, solve log base 10 of x as 3. So that's the answer that you're looking here. So this is 10 raised to 3. Base power, the term that you're trying to look at. Okay. Next, if your log base 10 of 1000. Now how it will be done? This is log base 10 of 10 raised to 3. The 3 comes out. So because it both have same this, so your 3 comes out. You have log base 10 of 10. So this is essentially 1 and this is 3. So your answer is 3. Okay. Next question. Here, they're trying to ask us to convert the log base 3 of 27 into exponential form. So log base 3 of 27 into an exponential form. Okay, so we want to convert this into exponential form. How it would be? So here in this case, this is 3 and this 27 right here is nothing but right 3 power 4. What you know here? So 9. 3 3 is a 9, 9 3 is a 27. So this is 3 power 3. So the answer that you get outside is 3. So this is the exponential format that we have converted it back. I didn't mean the exponential as e, adding an e there, okay? Even if you want to, you can add it and make the bases same. In this case, like that or something like that. You can convert it back. Okay. So in this case, this was the only exponential form that I was expecting here. Okay. Next question, we want to evaluate log base 2 of 64. So what is 64 as? 64 is log base 2 of, what is 64? 64 is, 2 raised to 5 is 32 and 64 is plus 1, so 2 raised to 6. The answer is 6 here. Okay. Next one, log base 10 of x. Log base 10 of x is given as 2. So you need to solve for x. So how will you do? You know that this is the answer that you're looking for. So this is equals to, this goes here. So 10 raised to 2, which is nothing but 100. Okay, that's it. Next question is pretty nice. So you need to simplify this term. Simplify ln of EQ. Okay, how do you do that? So now you already know since it's ln written, so this is log base E and it's written as E raised to 3. So both are same bases. So you can directly take this outside. So you have 3. Okay. So don't be worried or scared when you look at the problem. Just see how it's written. You'll be able to solve it back. Okay. Most of the bigger problems have like very small solutions. Now here, solve e raised to x is equals to e raised to 4. Now how will we do this? Think on it. So we had similar questions like this where our bases are same, exponentials are 1 to 1. So we can do what? Right? So in this case, our base are same. So we can equate the exponentials back, okay, to each other. So x is equals to 4. That's it. Okay. Next question. If I have log base 2 of x as 6, so I need to compute find x. Similar to the previous ones. So my x in this case would be 2 raised to 6, which is nothing but 64. Okay, that's it. Another question. Simplify. We have like completed all questions, so I won't post in the solutions. You can even either have a look to the assignment questions right here. So you'll be able to see exponential EL5. Okay, now how do you solve this one? So we know that this is e power natural log base e of 5. Now I can automatically change bases here, right? We can change bases here. Can we do that? So when it is something as this, it is directly cancelable. They both cancel out each other. So your answer right here is 5. Okay, that's it. So I had this many questions. We have like completed a total of 54 questions till now. If you have any further questions, do let me know. Any doubts, you can also post it in the Q&A. Either NPTEL TAs will help in you through there, or you can post in the YouTube week lectures that I posted online. You can add your comments or doubts there. So I will also be able to help you there. That's it then. Other way, so those are like the two ways to seek help from that, Vienna. Okay. So we pretty much covered everything. We had like differentiation, then we went into integration, then we saw the vectors and dot products. From there we went into current flows, diffusions, and differential equations. After the differential equations, we also saw two different paths for exponential growth and exponential decays, and later we went into logarithms and exponentials. There also we looked into this forms here. So I had like almost all properties were covered. I wanted to add in Taylor series, but it's fine. It's like more of something that, and for Taylor series and Maclaurin series, you know the formulas for them. If not, go into week 2. In week 2, we have solved them back. For log also in week 2, I've added a like a brief notes on the on the lecture slides folder, so you can also have a look into that. Okay. I'll stay in the session for 5 more minutes because it was like meant to be for 1 an hour. So that's it for today. Then thanks. If you have further questions, do let me know. Okay. So let's just see on the discussion forum if you have further questions. If people have posted their questions there, I can solve it here. Hmm. Let me share my screen. Yeah. Okay, I hope the platform is similar for you also. So from here, the problem solving session, you can go in for this recording. You can also fill the feedback form uh, if you have any further queries there. And this is a sheet that I update daily, so you can have a look through the sheet. All the problems that we solve now, and during the online sessions, the things that we discuss will be posted in this particular folder link, and these are like the links for the YouTube lectures. Okay. Now let's just see the Q&A here. Okay. So someone has a doubt for the questions. A doubt to be considered when calculating diffusion constant. This is reference to question 4 in assignment 6. The values is given in Celsius. Do we have to take the same value? If we have to convert in Kelvin, answers will vary if we take, since Boltzmann constant remains the same in both cases. So I do know that the value for Boltzmann constant with respect to the units that we have, the 4.21, it is with respect to Kelvin only. So you always will need to convert. Please guide us on one. Okay. So the answer for the TA says that unit is in Kelvin. Yeah, the thermodynamic calculations use it in Kelvin. All energy temperature relationships use in Kelvin. So you should convert it back. So yeah. Yes. Any other question? So, okay, someone had a problem with units and yeah, yes, they're saying that don't write units there, only use numbers. One had a problem with second derivatives here. Okay, for the curves. Yeah, so it's just a curvature and not slope, positive, negative. Mm, this is something else. One has a problem regarding radiant and degrees. So I guess NPTEL people will reply to this. So how is radian and pi related to each other? So both are like units of full circle whenever you're trying to look at. So theta is 360 degrees, and when you take a radian, it would be as theta by 360. Sorry, yeah, it would be pi by 180. And whenever you're trying to convert a degree back into radian, it would be 180 by pi. Okay. And that's it. I guess there are no further questions in this assignment ones. So let's just see. When we'll have a lecture on Tuesday, we'll discuss about week 7 because week 6 we are already done. So we'll discuss about week 7. That's Nernst equation, Fourier series, Fourier transform, and stats. Okay, so we only have like 5 lectures, and then the weekly assignment for it. Let's see. Yeah, that's nice. So the assignment is due on 11th March, and our session is on Tuesday. Okay, so you have a day to solve it. However, the questions I do feel that you, okay, Fourier series is something new for you, but for the other questions, till now you can solve it. Some are regarding the periodicity of functions, so it's fine. Here you can look. You can look into the function if it's even or odd, and accordingly you can solve it back. Um, Biomolecule, okay, that's Fourier series. Definite integrals, definitely till now you can solve it. I hope that you know how to solve them now. Periodic nature functions, just look that f of x has f of minus x and f of x has minus of f of x. From there you'll get even and odd functions. Okay. Then we have week 8 left. So in week 8, there are like basics of biostats. Okay, so we have like spectral features, simple statistical features. So mean standard deviation, frequency, PDFs. We have a binomial distribution, normal distribution, hypothesis testing. So I do think so that this session was this course was more about getting you introduced to this small concepts, and later you can follow back. So here you'll get all the lecture folders. So whatever the prof teaches in class, you'll get everything here. The formula that last time someone asked in session C, the formula is written right here, that velocity is F by 6 pi A. Okay, that's there. So that is your all study materials, and let's see if the book is here. Last time I asked them that to add a book. Yeah, so they have added the book for the course content, and that's a PDF, so you can always go and download that PDF. I'll also add it and download in the lecture sessions. Okay, so that's the same PDF that Prof has suggested to all of us. Oh no, that's not a book, but it's the session slides that he's teaching with the transcripts of it. So it's nice for people who do not get enough time to look into this session slides and all. You can always go and just read the whole document and you're done with the course. Yeah, that's still 661 slides here. Okay. Okay, then thanks for joining today. The session was nice and fruitful. If you have further questions, do let me know in the YouTube. Or else Tuesday, whenever will meet, that time also you can let me know if you have further questions. Okay. Okay. Thank you. Bye bye.